Oh, hi, I'm Jen Blank, and I'm a research scientist at NASA Ames Research Center in Mountain View, California. This is about less than, I guess, a quarter mile from Google, so it's right in the heart of Silicon Valley. And I'm an astrobiologist for NASA. I'm a NASA scientist, and I work on a few projects, one of which is the Mars Science Laboratory Science Team. So I've been working with this team for about 10 years, and since before we launched, to the time we launched in 2012, and then now we were just finished, actually 2011, excuse me, and we've just finished about 6 years on Mars. So I work on one of the science instruments associated with the Curiosity rover. That's the Mars Science Laboratory, right? Yep. In fact, here's my shirt to celebrate 5 years. And people will have heard of that in New Zealand. Oh, they will? Okay, yeah, Curiosity. Yeah. And most of our scientists are affiliated with one instrument, although we are all given access to all of the data that comes down from Curiosity. And I work on the ChemCam instrument, and this is the first interplanetary laser. So it's sort of a scout chemistry. We can fire the laser up to 7 meters away from the rover, pew pew, and then interrogate whatever we're targeting and figure out what the chemistry is. There are other instruments on Curiosity that tell us a little more about the mineralogy, maybe any organic compounds on Mars, but with ChemCam we've actually fired that laser over 600,000 times. So this is huge.
So how does it work? Do you control it from Earth, or does it do its own thing? Or
we control it from Earth. We have little recipes essentially, which will say what we want to do. Do we want to fire one spot many times? Because by firing repeatedly, we can get through the dust that covers a lot of the Martian, almost the whole surface of Mars. So we can penetrate up to about 1 millimeter, and then get through the dust into the original rock. But we can also do rasters, where we can program the laser to make little patterns. So like a 3x3 or a 1x5, and that's just little tiny target spots that are less than 1 millimeter adjacent to one another.
So is it almost like playing video games, is it? Space Invaders or something?
Well, except it's very slow, and compared to Space Invaders, it's not quite as dramatic because we're firing on a rock, or maybe some sand. But for us, it's thrilling because we get the data back, and then it becomes a mystery essentially to find out how the data what the data can tell us about the composition of the Martian surface.
So I guess there's a bit of a delay, isn't there, between communication from Earth to Mars, isn't there?
There is, and we have 3 satellites. Well, there are many satellites orbiting Mars, but 3 in particular that help us relay data from the rover back up to the satellites and then down to Earth. Yep. Curiosity does have a relay capability on itself, but it's sort of for backup purposes. The satellites are much more agile and are moving around Mars, and so better positioned to send information back to Earth. So we send data after every Martian day back to Earth, whether it's pictures that didn't fit in an earlier, or data that didn't fit in an earlier day, or actually information from that very day on Mars. So we get the data.
Same day.
Yeah, we get same day results.
So it's just a matter of hours to go between, is it?
Yeah, it takes a matter of minutes actually.
A matter of minutes. Yeah. So is it traveling at the speed of light? Is it? Or?
No, it's mostly speed of sound.
Speed of sound.
Yeah.
Oh, okay.
So and radio waves, radio transponder, and we depending on. You probably know that the Earth has a pretty concentric rotational axis around the Sun, but Mars has a very oblique axis of rotation. So there's sometimes like next year, or I guess this is 2018, 2 years from now, Earth and Mars will be close together. And this year, actually, last month, Earth and Mars were very close together. But then in contrast, there are times when Mars is further away on that rotational path, and so then it will take twice as long for information to reach. To communicate between Earth and Mars. And we also have operational roles. So I'm one of the people who helps plan what we're going to do on Mars for the science activities, and that means I'll be looking at images that have come down from a prior day, and then with a team we'll pick targets to interrogate, or targets where we want to sample, or even sometimes places where we want to drill a hole on the surface and bring that material into the rover. Those take a lot of planning, because to drill it in the 6 years we've been on Mars, we've only drilled, I think, 15 or 16 holes. So it's just very, very slow. And so it takes a lot of advanced planning, and we're trying to characterize the period of Mars history that covers almost 1 billion years of time. So we think in the earliest part of Mars history, the planet was wet, and had water on the surface. In fact, we've been able to show with the Curiosity mission that part of the crater we landed in once had drinking water in it.
Oh, okay.
So that's probably the biggest discovery of the mission, which was to look at Martian habitability. So, and on the side, I also look at places on Earth that might be considered good analogs for Mars or other planets.
You spend a lot of time in caves, don't you?
Oh, you're just recently, I just came back from about 3 weeks in lava caves, and there I was leading a group, and we were looking at the microbial communities that live in the caves, live off the energy from the water and from the rock, but also leading a mission simulation where we had a NASA rover moving down into the cave and mapping and imaging with spectrometers and cameras, imaging the sides of the cave wall, looking for signs of life.
Okay, so the rover's going inside the caves on Mars.
Yeah. Well, in California, but we think we think we've seen caves on Mars, and we have proof of that there are caves on the Moon.
Yeah.
We've been able. The Japanese Zealand project has been able to identify cavities underground on the Moon.
Okay.
So
because there's really quite big volcanoes on Mars, isn't
yeah,
there? So there could well be lava caves.
Well, we
there,
think
there?
from orbit we've seen caves.
Yeah.
So we just haven't gone inside yet.
Just haven't
And so
got to them
I'm
yet,
I'm a big advocate that we should go look for caves and go inside caves, not only as a place to look for life, microbial life, but also as a place to go if we're going to colonize Mars, because it would be a safe environment that would protect us from harsh solar radiation, and also it might be easier to access the subsurface and have essentially, you wouldn't have to build new structures, you could just contain hollow spaces inside a structure that's already made.
Yeah.
So.
And I guess those are the types of places where we're likely to find life, isn't it? Because it's there all on the surface, but in the caves or under the ice, it might be.
Well, we think if life exists on Mars today, it'll probably be in the it's probably in the subsurface.
Yeah.
Exactly, that's exactly right. But also that if something's in the subsurface, it's preserved in the subsurface. Rather, it might have a better chance of surviving over geologic time. So in a cave gives us the easiest way to access the subsurface without drilling.
Oh,
and drilling's on another planet is pretty challenging.
And you've you said you had an interest in caves in New Zealand too, haven't you?
I do. I think the North Island is. I've tramped around a lot of the North Island, mostly for pleasure, but also interested in volcanics, and seen some of the caves around Auckland. And I know there are a few caves in the South Island here. I haven't been into them. I've heard they're relatively shallow, but these are volcanic caves. I have been in limestone caves in the South Island, and again for recreational. I've rappelled down and been in some underground rivers in New Zealand, and that was pretty awesome. But that was just on my vacation.
Yep.
So, have you done that?
Not really. No.
Okay. Yeah. Okay. And of course, I've seen the glowworms.
Oh
yeah. Yeah.
Yes.
So.
Yeah. So I guess from what you're saying that your research of going into caves that will in future I guess will come into use when these rovers are sent into the caves.
I hope so. And with the kids here are doing exercises to practice, or rather to mimic some of the activities that the astronauts would do in preparing for Mars missions.
Yep.
And one of the things the kids are learning is that it's actually hard. It's hard to communicate with a remote team and communicate effectively. And then it's hard to complete the task when they're wearing gloves, even if they're not wearing spacesuits. And so what we've been doing in the caves in Northern California is having a team on the surface directing the rover underground and learning what works and what doesn't, just really practicing to get better, to find out where the challenges and roadblocks are in getting ready for a rover mission to a Martian or another planetary cave.
Yeah. Okay. So you trial doing what you're going to do on Mars, on Earth. First.
Sure, many times. So we just finished our first season with the mission simulation in caves, and we'll do another one in a year. So we'll figure out what we did right, what we did wrong, how we could do it better.
So
and
it works. That the rovers do go into caves and they do find things.
Yeah. Well, and also we're using one of the NASA Ames rovers that's used for mission simulations here on Earth, and obviously the planetary rover will probably be a lot different, probably be a lot more expensive.
I guess one of the risks, isn't it, that if there is life inside these caves, that there's always the risk that you could contaminate, isn't it? So I guess that's
true. We have something called NASA has a Planetary Protection office, and you might think it means protect Earth from space invaders, but it's actually protecting the other planets from contamination by Earth. And we actually one advantage about going back to the moon, and you perhaps heard that NASA's been directed to take people back to the moon before going to Mars now. With our current administration, is that the moon we think is a sterile environment, so it gives us opportunity to practice how to go to visit the moon and keep it clean from Earth contamination, and we think we'll be able to see if we contaminate the moon.
So you don't think there would be microbial life on the moon? Or?
We don't expect there to be, although we
know. To be on Mars.
Yeah, and we may have contaminated the moon with the Apollo program. We don't really know. Or with some of the other countries who've sent rovers, like China or the Soviet Union, who sent rovers and landers to the moon. We just don't know.
So there's 3 countries that have been to the moon.
Yeah. So.
And I guess there's several that have been to Mars now, isn't there?
Well, only NASA's made it there.
I was the only one that's landed so far.
Yeah, the Japanese sent a lander to a planet, one of the moons on Mars, and it didn't. It was a Japanese-Russian mission, and the Russians sent some landers to Mars that stopped functioning. And ESA just last year sent a test lander to Mars that unfortunately crashed. But they're planning to send a rover.
NASA's got the only one with active.
Yeah, it does. Yeah.
But there's satellites, isn't there?
There are. India has a satellite, which is fantastic, and there are 3 orbiters from NASA right now, and then ESA has an orbiter. So it's pretty exciting. Yeah.
There's going to be lots going to Mars.
I know. It sounds like there's going to be a lot of traffic, but in reality, it's a big planet. Even though it's not as big as Earth, it's still a big planet. So if we think about it, we're just touching down a few places. There's still a lot to explore.
We're only scratching the surface, in other words.
Yeah, exactly. And in fact, with Curiosity, we've only scratched the surface 5 centimeters. So the InSight mission, which is a lander, so it's like the Phoenix lander some years ago. InSight launched this May, and it's supposed to land in November, and that has a capability of drilling up to 1 meter down. They're going to put in a seismometer and try to sort of ascertain the structure, but more information about the structure of the Martian interior. And then when ExoMars lands on, it's the ESA rover, they're supposed to have a capability of drilling up to 2 meters. So that'll be quite exciting.
But I guess the capacity will still be limited until we get humans there, will it? Or the robots are quite effective, are they? Or?
Well, I guess our robots will get better. but another thing you realize is that when you work with robots, right now at least, things take longer, and there's something to be said for being able to touch things, so bring samples back to Earth, or be there in person where you can change your mind, and even though you see that rock, you want to look at that rock and that rock and that rock, or something.
I guess if there's people there on the spot, you've got the technology and the human factor too, haven't you? You've got both instead of at the moment you're just relying on the technology, aren't you?
Right, and being on the Curiosity team has really taught me how important it is to be able to touch things and smell things and walk around on things. It's fantastic to have this rover. It's gone, about 19.5 kilometers in 6 years, so not a very fast rover, but it's great to have it. Yeah.
Talked the other night about the possibility in future that you might be able to bring rocks back.
Right. We learned so much from the lunar program when we brought back rocks from the moon. We were able to confirm a lot of things. We have better chemical information now from our onboard instruments with the rovers, but you can learn so much more by being able to handle samples in the laboratories on Earth. So right now, with Mars 2020, they don't plan to bring samples back, but they're going to cache samples. So they have a whole system for inserting samples in a stowaway tube, and then at the end of the mission, or at some point, they're going to drop a whole pile of these tubes, and then they'll be preserved in the state they were when they were sampled, and then the thought is they'll be retrieved at some point in the future.
Hopefully, you'll get permission to bring them back.
Yeah, the challenge is there is that because Mars is so vast and the missions are sort of few and expensive, if we cache a repository of samples and then decide to go back and get it, that means we're exploring the same spot, right? So we don't have that. We commit to going to one spot more than once, and there are pros and cons of doing that. So I think all of the scientists would like to touch the samples, though, or at least touch them with gloves. So.
Oh, that's good.